Also, there's an aspect there where you're democratizing sustainability expertise, because traditionally that's something that sits with a very small group. Maybe they're inside of your company, maybe you hire them as an outside consultant, but you don't want that to be something that happens when your design's already done, you've gone out for construction documents, you're thinking about the embodied carbon. Then no, you need to think about it very early in the design. So I think trying to attach that expertise as early as you possibly can, use it in the smartest way you can, to really think about that additional attribute when you're saying, do I want a mass timber building or do I want, steel or concrete? Thinking about those with that additional facet, thinking about the healthiness of your materials. You don't want the occupants of your building to get cancer one day because of your poor. I would just say, regardless of where you are on your journey of learning a computational kind of approach to design, start now in terms of upskilling yourself. So I think the best way to do that is through a tool like Dynamo or Grasshopper, and really just thinking in this kind of, if I want to accomplish X, I need to do Y and Z, and really thinking through input, process, output. That's as simple as it is. That's how a computer thinks. That makes any sense. So I think just thinking about you did, and I think the best kind of embodiment of that and statement is the ability to tack on a property like the embodied carbon of an object. Let's say that a column is a certain size, it's a certain volume, it has a certain mass associated with these kind of functional units. In addition to something like if it's made out of concrete, you'd have a water to cement ratio, right? So the properties that are defined can also now help to tap into something like the embodied carbon attributes. So if you attach an environmental product declaration, kind of is the embodiment of that data for the embodied carbon. If you attach that to your column now, and let's say that it's a volume-based EPD, you can now measure your embodied carbon as your design is kind of forming and flexing, or you add more columns, or you change out the material. You're able to attach these additional attributes that just make your design smarter, better for the environment. I think we're now just at that edge of starting to add on those environmental attributes kind of in mass. We want to be smart about that, obviously, and I think a little bit. Also, but that's what it is. However, you can actually use that object, all the properties inside of it, to be able to kind of parametrically control it if you want to. So if there are rules around something, let's say maybe the bay sizing that you might do for structural engineering, or duct sizing you might do for mechanical engineering, you can set up rules in something like a visual programming script or code. You can encode your domain expertise to be able to do some of those processes for you because of the attributes that live on the object. So the open source platform that Buro Happold open sourced in 2018 is called the Buildings and Habitats Object Model, because really it's about